Hello everyone, I am Nina Montesklaros. So now, before we proceed to the main concept of the application in differential equations, which is the flow or mixture problems, we will first discuss some science concepts that needed in this type of application. As aside from calculus, we also need to understand some basic concepts in engineering sciences.
So the first one, guys, is what we call the density. So the density is given by the Greek letter. So density is equals to mass per unit volume. So the density is also expressed in terms of density is equals to mass flow rate over volume flow rate. So mass flow rate means that it is just your mass flow rate is equals to mass per unit in time. Also, volume flow rate is just volume over time. So mass is also expressed in mass is equals to density times volume. So mass is equals to density times volume, also the same as mass flow rate is equals to the density times volume flow rate. So now you can proceed to the main concept of this application.
So suppose, guys, we have tank wherein we have here like a flowing fluid that is going inside the tank, and at the same time we have fluid that is flowing out of the tank. So the fluid that is going in of the tank has its density. So we have the density. Let's say density in a volume. This is density in a volume flow rate since it's flowing. So this liquid that is flowing out, we have here density that is flowing out. And volume fluid that is going out of the tank. And of course, our tank has volume of the fluid. Since the fluid flow here, so it has different density, different concentration while it's flowing inside the tank. So every time the density is changing, it's changing. So next, we are going to find the mass of concentration. It has salt and H2O. So here the concept is that time rate of change of mass, that is your mass flow rate, is equal to the difference in mass flow rate, that is your mass going in. Mass flow rate going in minus mass flow rate going out. Therefore here we can say that the time rate change of mass is equal to mass flow rate that is going in. So they have different density because of the different concentration. So that is volume in minus density that is going out times volume that is going out. Hello everyone, I am Rose Angela Dalida Isulan. Now we're going to proceed and discuss our second example of flow problem application. The problem number 2. A tank contains 100 gallons of water. A salt solution containing 2 pounds of salt per gallon flows in at the rate of 3 gallons per minute and the well-stirred mixture flows out at the same rate. When will the tank have 100 pounds of salt? So first, let's illustrate the figure. So the volume of the tank is 100 gallons. So this is 100 gallons. So then a salt solution containing 2 pounds of salt per gallon flows in. So the density of going in is, we have here 2 pounds of salt per gallon. Then the volume flow rate of solution that is going in, that given us 3 gallon per minute, and flows out at the same rate. So therefore the volume flow rate in is equal to the volume flow rate out. So the volume flow rate out is 3 gallon per minute. So the density of solution that is going out of the tank is mass over volume. So the volume is 100 gallons. So the condition is time is 0. So the mass of salt is, so look the problem. So a tank contains 100 gallons of water. So it means at time 0 we don't have a salt in our tank. Therefore the mass of salt is 0. So it's very important to analyze the problem. So at time 0 we don't have mass of salt here because it is pure water at initial time. At time greater than 0, so it has already salt solution because it poured the water here with a salt content. So this is solutions already, and goes out, it has solution. So I'm required to find what is the time wherein the mass of salt is 100 pounds. So let's find the required time. So the concept is, we have here the time rate of change of mass is equals to change of mass flow rate. So that is delta mass flow rate. So mass flow rate in is minus mass flow rate out. So density in times volume flow rate in minus density of solution going out times volume flow rate out. Substitute the given. So 2 pounds per gallon times volume flow rate in, that is which is 3, minus m over 100 times volume flow rate out, which is 3 gallon per minute. So this is differential of m with respect to time. Separation of variables. So dm with respect to t is equals to 6 minus 3 over 100 times m, or it can express as, so get the LCD, which is 600 minus 3 m all over 100. So let's do the separation of variables here. So differential of m all over 600 minus 3m, so it's equals to dt all over 100. So we integrate both sides. So the RQ or the derivative is 3dm. Since we don't have negative 3dm, so we need to put negative 3 here in the numerator. So that is the integral calculus. So balancing. So balance on the outside of the integral sign, which is negative 1/3. So negative 1/3 ln times 600 minus 3m is equals to t all over 100 plus constant of integration c. That's apply the boundary condition. So T is equals to 0 and mass of salt is equals to 0. So because at initial time of pure water inside our tank. So let's substitute negative 3n ln times 600 minus 3 times 0 is equals to 0 all over 100 plus c. So here we can say that c is equals to negative 1/3 ln 600. So let's find our final answer. So the question is, what is the time wherein the mass of salt inside the tank is 100 pounds? So negative 1/3 ln times 600 minus 3m is equals to t all over 100 plus c. So, but c is negative 1/3 ln 600. So this is 1/3 ln 600. So let's simplify this. So transpose, this is negative, so it's positive here. So t all over 100 is equals to 1/3 ln 600 minus 1/3 ln times 600 minus 3m. So t is equals to 1/3 ln 600 minus 1/3 ln times 600 minus 3m times 100. So let's substitute. T is the missing, then mass of salt is equals to 100. So T is equals to 100 times 1/3 ln 600 minus 1/3 ln times 600 minus 3 times 100. We can use the calculator to get the final answer. So the final answer is T is equals to 23.1 minutes. So the concentration of salt inside the tank is 100 pounds.
Good morning everyone, my name is Jocelyn Otero. For this video, I will going to discuss the first example of flow and mixtures theory. A cylindrical tank has 40 gallons of the salt solution containing 2 pounds dissolved salt per gallon. A salt solution of concentration 3 pounds salt per gallon flows into the tank at 4 gallons per minute. How much salt is in the tank at any time if the well-stirred mixture flows out at 4 gallons per minute?
Based on our problem, the question is how much salt in a time. So we have a given our density in, which is 3 pounds per gallon, and volume rate in is 4 gallons per minute. Density out is, we all know that our density formula is P equals mass over volume. So we don't have a mass, but we have a volume for T. So our volume rate out is 4 gallons per minute. So we use this formula to get a general solution. dm over dt. So equals mass flow rate in minus mass flow rate out. Our mass flow rate in is density in and volume in minus density out and volume out. So our density in is equivalent of 3 and volume in is 4 minus our density out, which is m over 40, times our volume out, which is 4. So the time rate change of mass equals 12 minus m over 10 equals 120 minus m over 10. So dm over 120 minus m equals dt over 10. So we integrate this by negative dm over 120 minus m and negative dt over 10. So our general solution is negative mn times 120 minus m equals time over 10 plus c. So, to get this mass, we use this formula. M equals density times volume. So, mass equals density times volume. If our time is 0, our density is 2 pounds per gallon, and we all know that our volume is 40 gallons. So, 2 times 40 is 80 pounds. So, back to our general solution, which is negative ln times 120 minus m and t over 10 plus c. So, we need to substitute our time, which is 0. So, we need to calculate this, our c. Our c is negative ln over negative ln 40. So, back to our general solution. Negative ln times 120 minus m equals t over 10 plus our c, which is negative ln 40. Just to transpose this, ln 40 over 120 minus m equals t over 10. So, we use exponential form. T over 10 equals 40 over 120 minus m. So, transpose this in terms of m. 120 minus m equals 40 over p over 10. So, m equals 120 minus 40 t over 10. So, simplify. So this is the mass of the salt in the tank at any given time. M equals 120 minus 40 negative t over 10. So that's the first example and the solution.
Good day, everyone!
In this video, we're going to discuss one of the application of differential equations.
The flows and mixtures problem.
So let's start!
Hello everyone, this is the brine solution experiment. So, mag-introduce sa sa among materials. So, this is the timer, pitcher,
The salt, ang water, o baso.
spoon.
Susunod, ato na i-mix ang salt sa water to make brine solution.
A few moments later. A few moments later.
And that's all for our presentation. And if you don't get it, just rewatch the video. Thank you and bye-bye.